Have you ever thought about what would happen if the internet just disappeared? Today, we're talking about a wild piece of tech that lets our devices create their own internet, pretty much anywhere, anytime, with no router in sight. It's called a wireless ad hoc network, and honestly, it might just be the invisible glue that holds our connected future together. All right, to really get what this is all about, let's start with a pretty intense scenario. Imagine you're in a situation where suddenly every single connection to the outside world is just gone. No, really, think about it. No Wi-Fi, no cell service, absolutely nothing. How are rescue teams supposed to coordinate? How do people even find each other? What do you do? And look, this isn't just some hypothetical, it's a very real problem. During major emergencies like an earthquake or a huge flood, the physical stuff we rely on, cell towers, internet cables, Wi-Fi routers, that's often the very first thing to get wiped out. Our whole modern communication grid is, well, way more fragile than we like to think. So what we need is a solution that doesn't depend on any of that existing gear. And the answer, believe it or not, is a network that literally creates itself, on the fly, using only the devices that are actually there at that moment. So how does this magic actually work? Let's pull back the curtain and break down what makes this technology so incredibly unique and, frankly, so powerful. Okay, so here's the official definition. The two words you absolutely need to remember are decentralized, which means there's no central boss, and no pre-existing infrastructure. The network is created ad hoc, which is just a fancy way of saying for this specific purpose, right here, right now. Think about your Wi-Fi at home, right? All your gadgets, your phone, your laptop, your TV, they all connect to that one little box, the router. If that router blinks out, boom, the whole network is toast. Well, in an ad hoc network, things are totally different. Every device talks directly to every other device it can reach. They form this incredible web, or a mesh, where every single device also acts as a router for its neighbors. It's kind of like a digital bucket brigade, where everyone helps pass the message along. And this quote just nails the core idea. In this kind of system, your phone or your computer isn't just using the network, it is the network. Every device, or node as we call it, is an active player, making sure the data gets where it needs to go. So, this all sounds really cool in theory, but where is it actually being used out in the real world? Well, the answer is probably in a lot more places than you'd guess. Ad hoc networks are basically the secret sauce in all of these fields. They're letting cars talk to each other on the highway, giving military units a secure connection in the middle of nowhere, and even helping swarms of drones coordinate their flight paths. It's all about creating communication where traditional networks just can't exist. Let's take vehicular ad hoc networks, or VANETs. Cars use this tech to create an instant network right there on the road. So imagine a car hits a patch of black ice. It can instantly and directly warn all the cars behind it. No cell tower needed. It's a huge leap forward for vehicle-to-vehicle safety. And in the military, these are called mobile ad hoc networks, or MANETs, and they are absolutely critical. Soldiers and drones can move into an area with zero infrastructure and, in seconds, form a secure private communication network. And because it's a mesh, if one device gets taken out, the network doesn't care. It just automatically finds a new path for the data. It's self-healing. All right, so let's boil it all down. What are the key benefits of going routerless? Well, it turns out this decentralized way of doing things has some serious advantages. These are pretty much the four pillars that make ad hoc networks so great. You've got incredible flexibility, because you can set them up literally anywhere. They're super robust, since there's no single point of failure to worry about. They can scale up easily, just add more devices, and deployment is almost instantaneous. This right here is the secret to their toughness. In a normal network, if that central hub dies, it's game over. But here, if one device drops out, the network just shrugs and finds another way. The data packets are simply rerouted through other nodes. It's brilliant. Okay, but it's not all a walk in the park. Building a stable network out of a bunch of moving parts that are constantly joining and leaving, well, that presents some pretty unique and very tricky engineering challenges. So you're basically facing these three big hurdles. First, routing. How do you find the best path for data when the map of the network is changing every second? Second, security. How do you keep things secure when there's no central gatekeeper to check IDs? And third, bandwidth. How do you manage a limited radio frequency when everyone's trying to talk at once? Now, to solve that routing problem, engineers came up with some really clever strategies. Proactive routing is like having your GPS running all the time. It constantly keeps a complete, up-to-date map of the whole network. It's thorough, but man, it uses a lot of power and data. On the flip side, you have reactive routing. This is more like stopping to ask for directions. It only figures out a route when you actually need to send something. And, as you can probably guess, hybrid approaches try to mix and match to get the best of both. And that brings us to a final, really big thought. We are barreling towards a future that's just jam-packed with smart devices, the whole Internet of Things. In that world, where devices outnumber people 10 to 1, could these decentralized, self-organizing networks become the new normal? Could they end up forming a completely new kind of internet, running right alongside the one we use today? It's a pretty wild question to think about.